we can review. This week we completed our examples over data types. We had examples over integers or whole numbers, decimals, the double data type. We were introduced to the keyword auto, and as you can see, auto allows a developer to create a variable with the keyword auto and assign it a value. C++ will determine the data type used by the developer. Here we have several data types, and notice that depending on which value is assigned, auto assigns the data type behind the scenes. We were introduced to the character data type, where we can create a variable and assign it one letter. Okay, so that's why it's character. We will talk more about this in the coming lectures. And we were also introduced to the special data type string, which requires special configuration to use. We have to include the string. We have to state that we are using stud string. At that time, we can create and assign a value to the name variable, and we can output that string. If we come back over here and look at C++, the string is part of the C++ standard library right here. Thus, it needs a special configuration because it is not out of the box. It's not part of the C++ core language. The examples so far have been simple, mainly to give students time to get comfortable with how code is written in this class. So we write function prototype in the header. We write the code for the function prototype in the CPP. We always have to make sure we include .h. We will eventually use it in main. However, our steps are always, let's test new code first before using it in main. So we come here and we have written some code to test the get total function. Okay. Also went over the expressions, which are mainly rules, right? Rules that we are familiar with. For example, the order of precedence. We know that without parentheses, multiplication and division take priority over subtraction and addition. However, we can always use parentheses if we need to change the format of our code. We were introduced to casting. Some of it is automatically, some of it is not. If we are working with a double and an integer, the integer, in this case years, will be converted to double before the multiplication takes place. Afterward, a double value will be returned. If we are doing the opposite, converting a double to an integer, the double will lose its decimal portion. So if we send in the value 20.9 and we return the value, we will get the value 20. We can also force the data type to cast. In this case, a double to an integer. We are saying whatever value comes in, cast it to an integer and return the value. Okay. We also learned about overflow and underflow. So if we come back and look at the diagram that I created, so we know that if an integer is held in 4 bytes of memory, and we proved that with a test case. So we wrote this code and we said return size of. Afterward, we came in here, created a test case, and we proved that the size of integer in memory is 4 bytes. So if 1 byte is 8 bits, then 4 bytes is 1, 2, 3, 4, 32 bits. So 32 bits, or 2 to the 32nd, produces this value right here. If we assign a value, let me go to the main.cpp for expressions, overflow, main. If we assign a value to a variable of integer type and we add 1 to it, we assign it the max value that an integer can hold. In this case, if all of these zeros were ones, it will produce this value. If we add 1 to it, then we are 1 beyond the max value that an integer can hold, and C++ produces inconsistent results. We also learned that we can go to the opposite extreme, which is storing the smallest supported double value or decimal value using the special function that's in the climits include header. We can get the smallest value that this computer CPU can hold, and then we divide by 10, then we can go beyond the value that C++ can store, and we will also get inconsistent results. Okay, we talked about constants. A constant is a value that we know will persist or keep its value, and we may not change the value of a constant. For example, here we use the keyword or the numerical value pi. I know we just went a few decimals to the right. The point being, we want to use it as a constant. We went and wrote some code to use pi, and it's important to understand that you may not change the value of pi when this program runs. If you want to change the value of pi, you have to stop the program, update this value, run the program again, and at that time it will have a new value. And finally, I've uploaded plenty of videos to show students more about GitHub. I did talk about this. I will make sure that students are checking in code that works with the help of the GitHub actions. So anytime you check in code, a trigger will fire off a C++ compiler on the cloud. It'll check your syntax, it'll build, it'll create an executable, and it'll run the test cases. If your test cases are read, then there will be points off. If your code does not compile on the cloud, there will be points off. So please keep this in mind. Okay, and that is it for this week in review.